होतोय साइन नाही करत बिलकुल काय माहिती मी कुठे चालली झालं का कॉपी करून तर नाही ना व्हेरी स्लो एकदम स्लो बच्ची तू पण ना प्रशंसा एकत्र बसतात आणि मग गप्पा गोष्टी ना तू शांत निहाली है ना तू शांत आहेस तू तर चुप बस शांत महाराष्ट्र नहीं है ना सेक्टर के पास छोटा चैप्टर है छोटा है हाँ छोटा है थोड़ा छोटा है कपड़ों के बुक छोटे ये सरीसम में नहीं बहुत लेक्चर तेवढंच करायचं सरांनी केलं ना सर बोलले ना तेवढंच करा आणि हा असं फर्स्ट टाइम सेकंड मेसेज पण मंदिरा फर्स्ट टाइम नोटबुक काढायचं काय नोट्स काढायचं फर्स्ट टाइम तेवढंच करायचं आम्ही विचारलं की फर्स्ट सेकंड मध्ये पूर्ण सरांकडेच आहे काय भेटली चला भेटली हारली नेक्स्ट एग्जाम कब है ए तू टैक्सी कर 28 नहीं जुलाई आला में आज देख चुकी है छुट्टी अरे इस फाइनल मंथ 28 मला विद्यार्थी पेरेंट्स परत चला हमारा बोलते थोड़ा शुरू कैसे कंपल्सरी है त्याने आज देता नाही त्याची पण परत
एक फक्त टेस्टसाठी आली पुन्हा जावं
प्रिन्सिपल पण असणार आहे ना सर
प्रिन्सिपल सगळे असतात
प्रिन्सिपलच अरे आम्ही अरे स्टार्ट करत होती की एक जणांना विचारतात सगळ्यांबद्दल मुलाखत बोलतो सगळं त्या दिवशी ते
सांगते
आपल्याला काय
काय टीचर सांगते नाही लोक सगळे माझे एकदा विषयामध्ये नाव आले टॉकिंग
आता आले ना
एकदा मी काय विचारत
दीपक होता ना
त्याचं विचारायला दोघे तो बोलत नव्हतं मी एकटाच बोलत होतो सगळ्यांचं नाव बाकी सगळे आहेत ना मॅथ्स सगळे वाचायला
शाळेत थोडासा समजत नाही शाळा
नीलश्री पण ओळखते थोडं
ती पण चांगली बोलायला
नीलश्री ओळखते
नीलश्री मिस पण चांगली बोलते
अजून कोण ओळखते चेहऱ्याने ओळखते
मराठी मिस खायला पण
बोलत असं काय भरोसा नाही तिचा ते त्याने शोधलं होतं बसून त्यांना काय माहिती मग
So only you today? How many absents?
4.
क्यों क्या हुआ? Yes?
No sir.
Where? I think last class you missed. So they just decided just like that not to come. So I think in the last class we finished. What did we do in the last class? I don't know.
Spectrum.
We had started spectrum.
Yes. Common properties of electromagnetic waves.
अच्छा वो सब कर भी दिया था और क्या किया था apart from common? Did we do deviation?
Yes.
So we already started spectrum. So anybody remembers what is spectrum? Who was present in the last class from girls side? 3 of you. Okay. And you were present, right? So spectrum पता है क्या होता है? So first of all देखो क्या होता है? You have a sun which is the source of light, right? So when you analyze the light coming from sun, okay? So this is basically white light, right? So this is the visible light, okay? It makes us see things around us because of white light. Whenever any light falls on the object and when it gets reflected from the object, that is when we are able to see the things. This we know. When this white light, okay, is made to pass through prism, then what happens? When this white light, let us say this is the source of white light, say electric bulb or anything, right? Source of light. This is what we discussed in the last class. So, and when we keep a screen, white screen over here, right? Like a board is a white screen, right? So what we get is, we get band of colors on the screen. The color at the bottom is violet and at the top is red. Okay? And in between you have indigo, blue, green, yellow, orange and red. Okay? So what happens? So what happens is at this point, right? There is a splitting of color takes place. Right? Why so? Because the refractive index is inversely proportional to the wavelength of the light ray. Okay? So wavelength determines the color of the light. Okay? Wavelength governs color of light. This you don't remember, right? So basically, what is the wavelength of red color? It is roughly 8,000 angstrom. Okay, and what is the wavelength of violet color? 4,000 angstrom. Right? So before white light, if you take single color light, okay, and then you measure the angle of deviation, right? So when the angle of incidence is same for all the different lights, if the angle of incidence, if you keep on changing your light, let's say first you did with red, you get this as the angle of deviation. This is the original direction, so what is the angle of deviation for red? This was the angle of deviation, R. But with this, when you change this red light with violet light, you got the angle of deviation as something else. Now the angle of deviation is red color. So violet color deviates more and red color deviates less. Right? Why the deviations are different? Deviation is the bending of the light. Okay? Why the deviations are different? Because the refractive index is different for different color of light. Because it depends inversely on the wavelength. Right? So the refractive index is less for red color because wavelength is maximum for red. So it will be least refractive index. Least refractive index means least bending. Got it? And therefore the speed of red color will be fast. Okay? So why speed is fast? Because speed depends on wavelength. It is directly proportional to wavelength. तो जिसका wavelength ज़्यादा होगा उसका speed ज़्यादा होगा. ठीक है? So red color travels with fastest speed and violet color travels with less speed. In the same refracting medium, the speeds are different for different colors. That's why this deviation happens, and this we discussed in the last class. Okay. So due to different speeds of different colors, their bendings are different, and therefore we get a colored band on the screen outside. Okay. So this splitting of color inside the prism, splitting of colors. What do we call it? It's called dispersion. Understood? So dispersion is happening due to refraction at face AB. And this refraction is different for different colors, that's why different bending. So this splitting is called dispersion. And then on face AC only deviation is taking place. Deviation means refraction is taking place. Got it? So therefore we are getting this color in orderly arrangement. What is the arrangement? The wavelength decreases gradually as you go from red to violet. So this ordered arrangement of light is called spectrum. This is called spectrum, and this spectrum is of white light. This is called spectrum of white light. Okay, so we have red color. So start करके we are going till violet color in this order with pure. 7 colors are there, 1 and 2. So all this rainbow color. Okay. This orderly arrangement is called spectrum. This definition I have given to you. देखो यार spectrum दिखाया है. Go ahead, next page. लिखा है ना? That's what I'm saying.
Yes.
बगैर देखे no sir. सबने लिखा होगा, ठीक है? So the ordered arrangement of color in either increasing or decreasing order of wavelength is called spectrum. And since it is for white light, it is called spectrum of white light. Now, what is electromagnetic spectrum? This also was covered. Now, what is electromagnetic spectrum? देखो, when we analyze sunlight, okay, it also has some other radiations which are not visible to our eyes. Okay, this visible light is part of the bigger spectrum. There are other radiations also, but those are not visible to us. So, if you arrange all the radiations that come from sun, right? So in all the radiation, the visible is very small part. Yes.
कल आपके दोनों भी हिस्ट्री के लेक्चर्स थे, टाइम टेबल चेक कर लेना। और साइंस आपने किया है? थैंक यू सर।
Okay. So this is the visible spectrum. Right? On the right side to this and on the left side to this, what we have is invisible spectrum. Right? So spectrum, when we say, it is again ordered arrangement of radiations, but these radiations are not visible to us. So these are basically waves of radiations. So light waves or light radiations. In general, it is called radiation. Okay? So radiation, because it carries energy. Light has energy. What is the source of energy to us? Sun. So light waves carry energy. So it is also called radiation. Okay? So these radiations, beyond red color, we have infrared. What do you have beyond red? Infrared. So as we go in this direction, right, the wavelength increases. Okay, as we go from left to right. Left to right. Wavelength increases. So infrared rays which are invisible, this part is invisible spectrum. So their wavelengths are bigger than red colors. It's more than 8,000. Go further, you'll have microwaves. Right? Go further, you'll have radio waves. So all the FM, etc. that you hear, okay, all those channels are broadcasted at radio as radio waves, right? All those signals. So what is the wave of maximum wavelength from which category? Radio waves. Because as you go on the right, the wavelength keeps on increasing. Here it is. You have to remember only for visible. 4,000 to 8,000. Here it need not be. And then remember this formula. V is equal to F lambda. Right? So you can calculate the frequency as V by lambda. And V for all these are all part of electromagnetic waves. Full. Magnetic spectrum is a big band of radiation, of which visible spectrum is a small part. Okay? So all of them travel with speed of light. So this is speed of light. All, whether this, what is the speed of light? 3 into, so it is basically represented as C, correct? C is equal to 3 into 10 raised to 8 meter per second. Right? So it is speed of light, which is also the speed with which infrared travels. So when you switch on the TV, right, you press the button, instantly TV gets switched on because it is traveling at a very fast 3 lakh kilometer in 1 second. That's very big. Same is the case for radio as well as microwave. So is it understood? On the red side you have infrared. On the violet side you have ultraviolet. Right? Further left is X-rays. Further left is gamma rays. So when you go from left to right, the wavelength increases, and when you go from right to left, the frequency increases. You go from right to left, what happens? Right? And energy is directly proportional to frequency. Energy of radiation depends on frequency. Since E is equal to H nu. Have you read this? So in the higher classes, if you have not read it already, H is Planck's constant into frequency. Wow, H nu. Okay. F and nu is frequency. So which wave will have highest energy? Most energetic? Gamma rays, because frequency is maximum rate, right? Understood? So exposure to gamma rays might annihilate us. Okay, annihilate means will disappear. It will burn us without leaving any traces. Okay, it will convert us into particles smaller than air molecules. So we will be just disappeared, gone.
X-rays are also harmful, right?
If so, that's why in a controlled exposure it is okay. But if you just are exposed for a longer duration, this will finish you off very soon.
And radio waves is okay.
Radio waves is okay, but we are already in the midst of this and all this, right? When we go to hotels, we see ultraviolet rays to repel the insects and all that, right? Those are ultraviolet, right? Then you have infrared rays. Okay. So in the last class we had already covered till here. Today we'll go further. Right? So in the electromagnetic spectrum, in your syllabus, we have to learn the common properties to all the rays. So common properties to all types of rays, all rays. This entire band of ordered arrangement of either increasing wavelength or increasing frequency is called electromagnetic spectrum. Why electromagnetic? Because these radiations are in the form of electric and magnetic field. Got it? Electric and magnetic field. E is electric, B is magnetic. So constantly they are basically energy, electric and magnetic field. Now more about it in higher classes. And that's why they are called as electromagnetic waves. So light also is electromagnetic waves, EM waves. Right? Everything from here to here, everything is electromagnetic waves. Is it understood? So what are common properties to all rays? Common is all of them travel at the same speed. All EM waves travel at same speed in vacuum or air, which is with 3 into 10, 3 into 8. This is the speed of all. Okay. Next, they all obeys law of reflection, refraction, continuous natural process. They all obey. They all of them undergo reflection, right? Whenever we encounter any obstacle, refraction through mediums. Okay? So whenever they hit the opaque object, they will be reflected. Whenever they hit the transparent object, they will undergo refraction. And the laws of reflection and refraction will be obeyed. You now know what is law of reflection and refraction, right? Yeah, what's the question? Ask me. Yeah,
She's asking you, how does radio waves
Go ahead. How does radio wave
work in absence of sunlight?
work in absence of sunlight? So they are the radiation by themselves. You don't need sunlight for it. And we can artificially create radio waves, like your mobile. It works on microwaves, not visible to you, right? So तुम बात तो कर लेते हो ना? So those signals are reaching you in the form of these waves. Okay? So machine से create करते हैं. ठीक है? Transmitter सुना है? Transmitter receiver. So transmitters transmits radio waves. तो तुम्हारा मोबाइल के अंदर ट्रांसमीटर भी है और रिसीवर भी है. When you speak, that is transmitted. The other person speaks. When you receive, it is receiver. So always the device has both the things, transmitter and receiver. It is called transreceiver. Communication engineering, you will learn about it. Okay? If you don't decide to be a doctor. You didn't guess the joke. Okay. Third, all EM waves travel at same speed over here. They all undergo reflection through the mediums. Okay? What else? Any medium to travel. They can travel in space. They do not require. So, what does it mean? Can they not travel through a medium? they do not require medium to travel. They can travel without and with medium. Like a glass में से ही तो आता है ना? Can I not receive a signal, mobile signal? So it can, through anything it crosses, right? Through the medium also it travels. Without the medium also it travels. Unlike sound wave. Sound wave requires a medium to travel. Without that it cannot, right? What else? They are transverse, right? They are transverse. What is the meaning of transverse? So EM wave consists of electric and magnetic field, okay? So it vibrates perpendicular to the direction of propagation of wave. Got it? Like when the wave is traveling like this, in this direction, the electric field is oscillating like this, perpendicular, matlab 90 degree. That's why it is called transverse. This magnetic field is also 90 degree. So whenever the particle of the medium oscillate perpendicular to the direction of propagation of wave, the wave is called transverse. So they are transverse wave. There is one more point. What is it?
They are not affected by electric and magnetic field.
So they are not deflected by electric and magnetic field. इसका क्या मतलब हुआ? जस्ट इसको याद कर लो, ठीक है? Electric and
it can pass through that also.
It can pass through it without deviating, without changing its path. Electric and magnetic field. Magnetic field. Because it is chargeless. It doesn't have electron or proton in it. If it was electron, then it is a charged particle. So if you apply electric field, it will get bent towards positive terminal. Okay? So EM waves, light waves doesn't have any charge. That's why. Okay? Since it is chargeless. Since it is chargeless. So in the electromagnetic spectrum, one you have to study common properties to all EM rays. Rays are all electromagnetic waves. Waves or rays, anything you can call it. Okay? So how many types are there? 6, the 3 before, 3 after, and 1, 7. 7 types of EM waves are there. All 7 have these common properties. Clear? Apart from this, in your syllabus, you have properties and uses of ultrawave, ultraviolet rays, and infrared rays. Only these 2 are in your syllabus. In your book, everything is given. But you have to read only about these 3. Okay? So, there is a table given in the book. Let us understand with the help of the table. So, distinction between ultraviolet, visible and infrared radiation. I would request you to go through all this. It is in the textbook, not in the volume. Is it there in the volume? Only read the properties there.
X-ray's description is not coming.
No. Only ultraviolet and infrared. So in the notes you have gamma rays, X-rays, ultraviolet, everything. Just read ultraviolet rays. It is on page 101. Ultraviolet rays, visible light and infrared. Leave microwave radio. Okay? Page 101. You can read the in the book also and in the volume also. So you can read. So those who have Selena. You have Selena, everybody? घर में तो है. At home also you don't have Selena.
We have a different one.
अच्छा ठीक है चलो. But anyway, these things should be same. So ultraviolet radiation properties and shall I go through the volume then? Everybody has volume? Okay. So what is the wavelength of ultraviolet rays? So you just remember that it is from 100 angstrom to 4000 angstrom because 4000 was the limit for other, right? This is the range of wavelength. Okay, 100 angstrom to 4000. So we are discussing the properties of ultraviolet. See in the notes. How ultraviolet rays are produced through electric arc or electric spark. Have you seen the welding? Welding करते हो देखा? Very bright light. So such bright lights are called arc light. Or have you seen flood light? Very bright light is produced in flood areas. In during events, open ground, you have very bright lights. Stadium lights, those are arc lights, very bright. Okay. So in certain vicinity, they produce ultraviolet rays. Apart from visible, they also produce UV rays. Okay. So that is the source. What is the property? They are absorbed by glass prism, but not by quartz. So ultraviolet rays gets absorbed by glass. So you cannot use glass prism to obtain their spectrum. You have to use quartz for UV rays. Understood? So for white light spectrum you need a glass prism. But for UV ray spectrum you need quartz prism. Clear? Quartz is a transparent material just like glass only. So you must have seen, no? Casio watch. That cover is quartz. Okay? So it's not glass. Okay. So ultraviolet radiation can pass through quartz, but they are absorbed by glass. Right? Okay. Next is these radiations travel in a straight line with a speed of 3 into 10 raised to 8. It is a common property, right? It is an EM wave, so it will travel with the same speed as all other waves. So they will be scattered by the dust particle present in the atmosphere. Okay? They obey the law of reflection, which is already covered. They strongly affect the photographic plate as they are chemically more active. So what is photographic plate? Like X-ray film, no? That is a photographic plate. So when ultraviolet ray will be directed on the photographic plate, it will affect the photographic plate. Got it? So कुछ उस पे photo आ जाएगी. It will become patchy or whatever. Whenever UV rays are passed, it will not remain in its original condition. So it affects photographic plate. They produce fluorescence on striking a zinc sulfide screen. Right? So this is a property. So in old CRT TV, have you seen? Have you seen old TV? Not this. This is LCD. This is LED. Before that we had LCD. Right? Before that we had CRT, big picture tube and all that. So on that there is a coating of zinc sulfide. So whenever UV ray is incident on that, it becomes fluorescent. So fluorescent means what? If it is of green color, that green color will be enhanced. It will look fluorescent, like radiating kind of a thing. If there is any color, you put light on it, some color get more enhanced. That is called fluorescence. Okay? Like if you see the note, so have you seen to check the authenticity of the currency? Some people put light on it, so it becomes violet. Fusing violet coming out like that, they will feel. So that is fluorescence. Okay? Yeah. So they produce fluorescence on striking a zinc sulfide. They cause health hazards like skin cancer if our body is exposed to them for a long period. So one should avoid going out into direct sun, like in countries like Australia, etc. So there is a lot of UV rays present, right? So as you approach closer to what you call equator, so you have more threat of getting exposed to UV rays. So you should have your body covered and with proper appropriate clothes. Okay? So you should have some protection, sunscreen, your UV. Enough advertisements you see in television, right? So what are the uses of UV rays? So anything which you want me to explain more in properties? Uses for ultraviolet rays. It is used for sterilizing purpose. What is sterilizing? So operation tools, right? Doctors use operating tools, right? So before using it on patient, they should be completely sterilized. Clean. I mean, sterilize kill all the germs and bacteria on it. Okay. So once you expose them to UV rays, it will be automatically clean. It is also used for detecting purity of gem, egg, ghee, etc. Right? So if it is impure, it will show fluorescence of impurity. It will be highlighted, right? So that is what it will show. So if gem, you must have seen in movies, starts glittering, put UV rays, it will glitter more, right? With the impurities inside, it will become patchy, right? So you can easily detect that. It is used in producing vitamin D in food of plants and animals. So if you expose plants with UV rays, you will see that it will get better nourishment and the yield will be better, right? In a controlled environment, right? So it accelerates the vitamin D in plants and animals. So are you aware that when newborn babies, right, they are given UV lights? Mothers are supposed to take them out. The grandmas will carry the baby and show sunlight. It's basically for their bones to become stronger. So UV rays, but in cities like Mumbai, we hardly have any provision for sunlight. We live in flats. So basically, when the baby is born, there is neonatal care facility. I know because their parents went through all that hardship. So the some babies require extra UV rays, right, to get over the jaundice when the liver gets activated and all. So you should know this. So UV ray treatment, don't get scared. Okay. So because it is a rich source of vitamin D, which is good for bones, etc. Now, how do we detect? So we did the property of UV rays, then we learned the uses, and now how do we detect UV rays? Pata kaise chalega that it is a UV ray, right? So when UV rays pass through silver chloride, it turns violet and finally dark brown. So there is a chemical test to identify UV rays. क्या करेंगे? When we pass it through silver chloride solution, right? What happens to it? It turns violet initially, then finally it becomes dark brown. Then the rays were UV ray. So on page 102, right? Detection. Then second is they are chemically more active than visible light, hence they are called actinic rays. Oh, this is for memory sake. So they are chemically more active than visible, meaning if you expose any stuff with visible light, it may not affect it. But if you expose it with UV rays, it might show its effect. Okay? Like turning or changing of color, etc. Right? So the chemical reaction has taken place. Is it understood?
Yes.
Okay, run through visible light. What is the wavelength? 4000 angstrom to 8000 angstrom. What is source of visible light? Sun, electric bulb, hot objects. Because hot objects first turn red. When you heat them further, they become white. Okay? Extremely hot objects are almost white. What is the property of visible light? It helps us see objects around us. Okay? That's the visible light. Switch off this light, can you see each other? Yeah, means hardly. Okay. What are the uses of visible light? Photosynthesis and photography. And of course, letting us see objects around us. Okay. So with this, we are done with properties of visible light. Next is infrared radiations. Okay. So what is the wavelength of infrared radiation? You must know that it ranges from 8000, which is where red ray ended, and the infrared begins from there, up to 10 raised to 7 angstrom, is it? It is so very big range it has. Huh? So just remember this 10 raised to 7. And you can calculate frequency if asked. Sometimes they ask frequency, then you can calculate the range using this formula because V is always 3 into 10 raised to 8. Now substitute lambda to get frequency in hertz. Okay? So ऐसे करो. Okay, let's discuss infrared radiations. What are the source of infrared radiations? All hot bodies, all heated objects. So are we emitting infrared? Yes. Are we at 0 degree? 0 degree also is very high temperature. How much is that? 273 Kelvin. So 0 Kelvin पे हमारा infrared radiation बंद होगा. So there are thermograms of body. Have you heard about it? So when our body temperature is analyzed, thermograms, different colors will appear on our thermograms. That is basically analysis of infrared rays. So what is the source? All hot objects or heated objects. Properties. Common property, they will travel in straight lines, just like light or other EM waves. And with what speed?
3 into 10 raised to 8 per second.
Okay. In vacuum. Expect more questions, huh? People are sleeping or watching movies, huh? So be alert. So common properties. So some properties are common, right? So for all UV and infrared, we can have these 5 properties and additional 2-3 different properties. So second property is same as common. So they obey laws of reflection and refraction. If a source of heat, say infrared lamp, so there are infrared lamps. Like this is not infrared lamp. The one in restaurant to repel insects, etc. Those are infrared lamps. So if a source of heat, say an infrared lamp, is placed at a focus of parabolic mirror, a parallel infrared beam is obtained. So this is the source of infrared.
Ultraviolet also, right?
Yeah, you can have ultraviolet also.
Infrared will reduce.
Infrared is, I mix it up. Infrared, again, you have a bulb or source of infrared light. So when you go to a doctor to get some treatment, right? So you have a muscular pain, etc., right? So you go to a doctor to get that therapy. So what it does is exposes your organ to infrared rays. So it relaxes the muscular pain. Same you have for UV rays in the restaurant. That was the restaurant thing was for UV, not infrared. Infrared is at a doctor's place or in your TV remote control. Okay? So don't get confused just the way I got. Okay? Yeah. So a source of infrared lamp is placed at the focus of parabolic mirror. A parallel infrared beam is obtained, right? This you understood, right? The doctor has the equipment, so when the ray is exposed, all that ray is coming because in that instrument, let's say this is the concave mirror. So at its focus, the UV ray source is kept. So it is directed at the mirror and then it is coming back like this. Got it? So this source is kept here. So this infrared lamp is kept at the focus of this mirror. And therefore it comes out. Let's say this is the doctor's gadget. So then on the patient's organ, he can just expose it. Okay. So this is what it means. You may have a burning glass which focuses the infrared radiations of short wavelength from the sun on a paper due to the paper chars or burns. Have you done this experiment? Sunlight, you keep a paper and focus the sunlight. It will be focused in a very small region and it will burn a hole in the paper. Have you done that experiment? So we in our childhood used to do all this, right? So if you get a chance, do that. If you have a magnifying glass, same magnifying glasses can be used as a burning glass. So sun इधर है तो ऐसे रखो and keep the paper here. Then try to focus sun over here. It will be bright spot. In few seconds it will start burning. ठीक है? हम लोग हाथ पे भी करते थे. But don't do that, right? We really got burned sometime. Okay, next is they do not affect the ordinary photographic film. UV rays affect the photographic film because they are highly reactive. These are not. So they do not affect the photographic film. However, they affect a specially treated photographic film, right? So there is a different type of photographic film for infrared rays, right? If you still wanted to obtain photos with infrared rays, then a different photographic film will be needed, right? Acha. They also get absorbed by glass, just like UV rays, but they are not absorbed by rock salt. Rock salt, ठीक है? सेला नमक बोलते हैं उसको हिंदी में. So if you, that is also transparent, right? So if you use a prism of rock salt to obtain spectrum of infrared rays, okay? You cannot obtain spectrum using glass prism. Why?
It will absorb.
It will get absorbed, so it will not come up. Okay. They are detected by their heating property using a thermopile or a blackened bulb thermometer. So generally a thermometer has a transparent bulb, right? So when you touch it, immediately it starts rising. So when you blacken it, it will absorb the radiation faster. So the mercury level will shoot faster. Okay? So when a blackened bulb thermometer is used, you will see a rising of mercury level fast. So that means this is infrared ray. Yeah. Right? And thermopile is like, it works on hot and cold junction. Right? Thermopile is when two metals, right? So let us say you have so one is kept in hot, the other one is kept in cold, hot and cold. Right? Then the potential difference is created between the terminals. Okay, let's say this is minus, this is plus. Got it? So when the UV rays is when infrared ray is directed over here, then if you have a potential difference meter, it will show some deflection. Got it? So electricity can be produced in many ways. This is one of them. Thermopile, right? Thermopile or thermocouple also it is called.
The infrared rays pass in this circuit. Where does it pass?
Infrared will heat this junction, so the other one will. So there will be a heat difference. So potential difference will be created due to heat difference.
So that is in that we can observe.
In that sense, so initially both will be at the same potential, so it will show 0. Now when you expose one of the junctions to infrared, it will show some deflection. It's not given in the book. I'm just telling you from my side so that you understand. Okay? Because there is a word called thermopile used here.
So this is the setup for that.
Yes. Have I not shown you this in energy, work or energy chapter? Can you see thermocouple? This diagram, conversion of energy. Thermocouple, thermopile, okay, it's that. Conversion of energy, did we read in this slide? Yeah, few months ago, right?
We didn't do it from the textbook.
We did. Yes.
I was not there.
You were there.
No, sir. For energy, I was not there. For
Is it?
Yeah. We taught it during, I think, May time.
I don't know. You obviously have not done it, right? None of you have done it.
I was there for machines. I was not there for this.
Oh, this chapter has been taught, right? Work, power, energy. She will stand with me. Yeah, see. We did work, power, and energy, right? This is the second chapter. Don't tell me read yet. In this life we did. Okay. What next? So they are absorbed they are detected by their heating property using a thermopile or a blackened bulb thermometer. Both understood? What is thermopile? Something like this. Okay, this was called thermocouple in energy shell.
So they both are same, right?
Yeah, you can understand that. So obviously, slight difference is there. The thermopile would
they are
be
sending the infrared rays.
correct. No, no.
Then-
Listen, listen. This thermocouple is a general thing, right? Infrared is one way to heat it. You can have a stove or some other thing which can heat this. It is an external agent. In this case, we are saying infrared. We can heat it also. We can burn some fire below it. So anything which makes the temperature different of the two reservoirs. Understood? So this becomes a hot junction. This becomes a cold junction. So any agency which creates the difference in temperature of the two junctions will lead to potential difference. So here I am using infrared, but this thing is general. Understood? Nobody is going to ask you what is a thermopile. You just remember. So for memory's sake, I explained this so that it registers. Okay? No details on thermopile. It's just how you can detect the infrared rays. Now there are some interesting uses of infrared rays. What is the first use? Chalo, I'll make you all read. You read the first use. Read.
The infrared rays radiations are used for therapeutic purpose by doctors.
Yes, I explained that. What is the therapeutic use? Treatment of pain in the muscle. Okay? So you go, doctor was asked, सिखवाने के बोलते हैं ना आज डॉक्टर was मम्मी को लेके जा रहा हूँ उनको थोड़ा सिखाई देने का right? Sometimes use hot water bag ना just like hot water bag it will have a slow effect but if you take an infrared exposure immediately you will be relieved. Okay?
Temporary or permanent?
No, temporary.
Temporary.
A doctor, come on, doctor will keep on calling you. एक बार में हो गया तो how will whatever it is next month keeps. Okay. So they say you have to take a therapy and therapy is generally more number of times. Any therapy is a repeated procedure, right? Yeah. So, but if you are taking that hot water treatment at home, that also will help you, but that will be a longer process. This will be a faster process. That's how it is. Okay, next. Yeah.
They're using photography at night.
Why loud bolo na thoda? तो सुने तो हाँ.
They are using photography at night and also mist and fog because they are not much scattered, so they can penetrate appreciably through it.
So when you use infrared rays, now they are good because they don't get scattered. They have a long wavelength. Okay, so the particles are very small. They are not able to scatter. Okay, so rain में या mist में भी it can keep on traveling straight. So for photography during fog, right, or during night, okay, they are used. So in night also, the visibility can be obtained by soldiers, military personnel, right? So they use infrared rays for communication also because it doesn't get scattered. So the signals can be sent and it is invisible. So you can have secret communication sent through infrared rays. Got it? So is this point understood? They are used in photography at night, right? And also in mist and fog because they are not much scattered due to their longer wavelength. Okay? So they can penetrate appreciable distance through it. Okay. Next.
Infrared lamps are used in diaphragms for developing photograph since they do not affect the photographic film chemically but they provide some visibility.
Understood? बताओ क्या हुआ इसका meaning? So in this room, if I replace these tube lights with infrared lights, so the visibility will not be as clear as it is right now. So there will be a reddish hue, some lal thing. But that is very faint red. So I'll be able to recognize you. It will not be pitch dark. But then it will not affect the photographic film. So in old days, now we have digital. We click and instantly the image is ready. But if you want to get the image on paper, right? So it had to be developed. So infrared rays does not affect the photographic plate. So whatever impression is there when we develop, we only get whatever was optically captured through the camera. So infrared rays do not affect my photographic plate. Matlab they don't impose on already taken photograph. But in the dark room, I can use them for visibility. Understood? नहीं समझा ना? पुरानी फिल्म देखी क्या जिसमें फोटो ऐसा लाल कमरे में ऐसे टांगते हैं फोटो? हाँ देखा? So that is what they're using it for, only for visibility in the dark room. But जो फोटो नेगेटिव लिया है ना, नेगेटिव आता था ना पहले फोटो, याद है? पुराना कैमरा याद है? तो पैदा ही नहीं होगे, तुम्हारे पैदा होने से बहुत पहले खत्म हो गया. When we were kids like you, we used to have camera with a negative in it. Roll. Fujifilm. Just search on that. Fujifilm. Okay. So that roll used to be fitted. And when we click, एक frame ऐसा आगे बढ़ता था. एक picture लिया, आगे आया. So you have limited 20, 30 उतने ही खींच सकते थे. आज के ऐसा नहीं है. Unlimited खींचते जा रहे हो because it's on the memory card. So that roll will proceed after every click. तो 25, 30, 36 फोटो आप 36 photos खींच सकते हैं, depending upon the roll size. Got it? Kodak. Have you heard about Kodak? Kodak film. Kodak is the roll. These were the guys who were manufacturing those rolls. They are not out of business now. After this digital cameras, right? Now you can click the photo and see it on the mobile. Who goes for developing? But when you take passport photos for your school, so they develop paper पे ऐसे print out भी लेके कर सकता है और they can develop those photographs. So development, when they are developing that photograph, so if it is sunlight, then it will expose your photo. मतलब पूरा white दिखेगा, full white हो जाएगा. But if it is infrared, it will not spoil the photograph because it doesn't affect the negative. Got it? But in the dark room, all that development activity is carried out in dark room. तो देखने के लिए कुछ तो चाहिए. That light is infrared because ये light लोगे तो फोटो खराब हो जाएगा. समझ में आया? That's what it is. Okay. So infrared lamps are used in dark rooms for developing photographs since they do not affect the photographic film chemically, but they provide some visibility. Okay. Next point. They are used as signals during the war as they are not visible. I told you that infrared rays are invisible. But when they are used inside closed room, they allow some visibility to us, but not like white light. Okay, reddish. Yeah. So they are used as signal during the war as they are not visible and they are not absorbed much in the video. So you don't get confused with the previous point and this point. You said in the room they are used for some visibility, and now we are saying it is not visible. So for signal, very thin ray is sent. Okay, in the room, like everything is closed environment. Okay, so like when you use your TV remote, you don't see कि यहाँ से laser ray निकल के जा रही है, ऐसा नहीं दिखता ना तुमको. So you just operate it just like that, right?
The signals to contact, right?
Yeah, the signals. The signals coming to your mobile are they visible to you like a water flow?
So then they can use radio waves.
Where?
For wars. During wars, they can use radio waves.
But the radio waves, if there is a bad weather, etc., right? So as you go from here to here, the energy increases. So infrared has energy greater than micro as well as radio. So you need strong wave. So during wars, right? So this will penetrate longer distance. That's what we learned, right? So this is less energetic. Okay? So that's it. So and they are not absorbed much in the medium. They are used in remote control of television and other gadgets. Okay? So any questions? All right. So with this, and scattering of light is not in the syllabus now. Okay, it is not in the syllabus for this year. Let me know if it is there. Cross verify in the next class. Let me know. As far as I know, it is not in the syllabus.
For this year's.
For this year, yeah. You plan to do 10th in the next year also? Yeah, so it's not for you. Happy? Yes, sir. Very happy. Because, there are some interesting things you are missing in this, right? Why the sky color is blue, right? What will be the sky color when you are like above atmosphere height? All those things you are missing, right? Anyway, so what are the numericals? We have time? We have 2 minutes. And there are 2 classes of numericals. Let's give 1 minute to each numerical. So, even if it exceeds a minute, just hold on, okay? So the electromagnetic, it's on page 107. Electromagnetic wave has frequency of, so given class of numerical 1. This is page 107. So given, what is given? Frequency is 500 megahertz. So mega means 10 raised to 6. Okay? So frequency is this. And wavelength of 60 centimeter. 60 centimeter is 60 into 10 raised to minus 2 meter. So we have frequency, we have wavelength. What calculate the velocity of the wave? So V is equal to F lambda, I told you. So this is 500 into 10 raised to 6 into 60 into 10 raised to minus 2. So what is the speed now? So 0.6, right? So 0.6 into 5 is, so 300 into 10 raised to 6, which is 3 into 10 raised to 8 meter per second. This is the speed which is expected, right? For any EM wave, the speed should be 3 into 10. Calculate the, name the medium through which it is traveling. So what should be the medium? Air or vacuum. Very good. Because the speed is this. Air or vacuum. Okay. So this was easy. Second is, I'll just tell you the formula, you can do the calculation yourself. So you have to now calculate the frequency, question 2. What is it? So since V is equal to F lambda, F is equal to V by lambda, right? So what is the wavelength given? Now speed is always 3 into 10 raised to 8. What is wavelength? 5500 angstrom is 10 raised to minus 10. So just simplify, right? So this will be like 3 by 55 2. So this will be how much? 10 raised to minus 12. So how is this going to be? 10 raised to 6 plus 10, right? 2 zeros are cut from here, so it will be 10 raised to 6 plus 10. This is 3 by 55 into 10 raised to 16. And when you solve this, you will get 5.4 into 10 raised to 14 hertz. Okay, these are the 2 numericals in this chapter. Rest is homework. There are many questions you should try. There is this thing, okay? One prism, if you keep, it splits, right? But when you keep an inverted prism, it joins them back and produces the same white color. this diagram. Let's go to it. First prism splits the color. The second prism converges and gives the white light again. Okay, same thing. तो ये डिफिकल्ट नहीं होना चाहिए समझने के लिए होगा तो नेक्स्ट क्लास में होगा Shall we end the session? Sure. Okay. Good night all.